This video will explain how to diagram arguments that contain singular propositions. So let's go back again to the kangaroo argument. The kangaroo argument says, all kangaroos are flying things. Karin is a kangaroo. Therefore, Karin is a flying thing. This argument is clearly valid, but how do we prove it? Now that we know how to deal with statements like Karin is a kangaroo, we can now diagram this argument and prove it is valid. So we will rewrite Karin is a kangaroo as K is a P and diagram it as follows. So this is just to review what we discussed in the video on diagramming singular propositions. So this is how we diagram Karin is a kangaroo when it's sort of in isolation. Next, we need to look at how we'll diagram it as part of an argument. So to extend that analysis to the full argument, we're going to stick as closely as possible to our standard Venn diagramming technique. And so we're going to still continue to use P for the predicate term in the argument and M for the middle term in the argument. The S will still be part of the diagram, but just as a placeholder, since there is no subject term in this argument, because the subject of the conclusion is a single individual, Karin, rather than a class, and same goes for the second premise. So how we'll translate this argument into sort of symbolic, how we'll formalize it, is we'll say all M are P, K is an M, because kangaroos is the middle term, because it appears in both of the premises. And then K is a P. So the predicate term is flying things. And then we have K standing for Karin. Okay, so we'll diagram this argument as follows. So we'll start by diagramming, we follow the same rule we did when diagramming arguments in general, is if there's a universal premise, we want to diagram that first before the singular premise, just like we diagram universal premises before we do particular premises. And the reason for this is exactly the same, because it might help us narrow down where to put, in this case, so in the case of particular statements, it's where to put the X. In the case of singular statements, it's where to put the letter that refers to the individual. So in this case, K. So we diagram all M are P, just like we always would. And then we have to place the K, for the K is an M. So we know that the K goes somewhere in the M circle. But most of the M circle is, all of the parts of the M circle that are not also part of the P circle are shaded in. So we know it can't go there, because that says there's nothing there. So that means it needs to go somewhere in this intersection of the P and the M circles, because that's all that's left of the M circle. However, we have the same problem we had when diagramming it as a singular statement, in that we don't know where in this intersection it goes. If we put the K in the part of the circle that's outside of where the S circle overlaps, well, then that's saying that K is an M and that K is a P, and that it's not an S. And we don't know that. So just from K is an M, we don't know its relationship to P. We also don't know anything about S, because it's not even really part of the argument. And likewise, if we put it in that little triangle in the middle, then that's saying that K is an M, and that it's a P, and that it's an S. And we don't know that. So we have to put it on the line that intersects that circle, that intersection of P and M. And then we just like in the other arguments, we want to look and see if the argument is valid. So what we need to do is we look to see if the statement K is a P is diagrammed in this argument. And so we ask, well, is there a thing, K, that is somewhere in the P circle? And the answer is yes. even though it's on the intersection, doesn't matter because that whole section there is within the P circle. So this argument is valid, and that's how we show it. Okay, let's look at another argument. Okay, so another example. All monkeys are things that like bananas. Amy is a thing that likes bananas. Therefore, Amy is a monkey. So we'll formalize this as all P are M. A is an M, A for Amy, and then A is a P, is the conclusion. Okay, so we'll diagram our universal premise first. So we fill in the part for all P are M. So we fill in all the parts of P that are not also part of M, because we know that all P are M, so there's nothing in this circle that's relevant to us in the P circle that's outside of the M. Okay, and then we have to place the A for A is an M. But you see, we have this whole circle. For the whole M circle is not filled in at all, so it could really go anywhere. And where we're going to put it, it's going to say different things about it. If we put it in the intersection of the P and the M circle, and we put it in the part that's outside of the S circle, then it would say that A is an M, and it's a P, and it's not an S. We don't know that. If we put it in the intersection of the S and the M circle, we put it in the part of the intersection that's outside of the P circle, that would say that A is an M, and it's an S, and it's not a P. And we don't know that. All we know is that it's an M. And if we put it in that place right in the middle where all three circles overlap, that would say that A is an M, and it's an S, and it's a P. We don't know that. Furthermore, we could put it in the part of the M circle that is outside the intersection of all the other circles. So put it in where it's just in the M circle. And you might think that's safe because we know A is an M. But that's saying more than just A is an M. That's saying that A is an M, and it's not an S, and it's not a P, and we don't know that. So it needs to go right in the intersection where everything comes together to put it on the line. Okay, and then we look and we see, is the conclusion diagrammed? So we want to see if the statement A is a P is diagrammed. And the answer is no, because the A is on the line, it's not definitely in the P, and it's not in the P. So it needs to be, in order for the statement A is a P to be true here, that A would need to be somewhere in that intersection of the P and the M circle, because that's all that's left of the P circle that isn't filled in. And that's not where it is. So this argument is invalid. So that's how this works with singular statements. It actually translates really, really well, which is why it surprised me that nobody else came up. This idea is entirely my own invention. I have not seen anyone else do it this way, but it works. And so it really surprises me, actually, that no one else has thought of this. But there we go.